Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one kind of question lost more marks than any other on last year's papers, the Sine rule ambiguous case. Students answer with the calculator angle, hand the paper in, and miss a second valid triangle. You can stop that from happening in under a minute.
Promise and preview. Today we focus on one thing, the Sine rule's ambiguous case, where SSA gives either 0, 1, or 2 triangles. By the end, you'll have an intuitive reason why this happens, the exact checks examiners expect, and a 30-second checklist to use in any SSA question.
Quick question before we start. When you say ambiguous, do you mean the calculator lies or the question is badly written?
Great question. Neither. The calculator gives one angle from an arcsine, but maths allows 2 possible angles that have the same sign. The ambiguity is a mathematical fact, not the calculator's fault. Let's see why. The concept, step 1, the sine rule itself. In any triangle, sine A over A equals sine B over B equals sine C over C. Say you know angle A and sides A and B. That's SSA. We set up sine B equals B times sine A over A. That's a perfectly valid equation, but note this. For a number x between 0 and 1, arcsine x gives an acute angle, and there is a second possible angle, 180 degrees minus that acute angle, with the same sine value.
Intuition. Imagine dropping a straight altitude from the top of a triangle to the base. If the given side A is shorter than that altitude, no triangle will reach the angle. No solution. If it's exactly that altitude, you get a right triangle. If it's a bit longer, 2 different peaks are possible, one acute triangle and one with an obtuse angle. That's the root of the ambiguous case.
So the 2 triangles are just reflections of each other across the altitude. That helps picture it.
Exactly. Picture the base fixed. The top vertex can sit on either side of the perpendicular line and still meet the length conditions. The maths says both are valid if the sine value is between 0 and 1 and other angle sums work out.
Now, the precise altitude test, something you can do before wasting time on your calculator. If you know angle A, side B, the side adjacent to A, and side A, the side opposite A, compute H equals B times sine A. Then, if A less than H, no triangle. If A equals H, one right triangle. If H less than A less than B, 2 possible triangles. If A greater than or equal to B, 1 triangle only. Keep that rule in your head. It's gold during exams.
Matter of fact. Examiner note. Label the triangle clearly. If 2 answers exist, write both and state which is which. Examiners award method marks for the correct process even if a student misses one final value, so show you're working.
The exam technique. Here's what wins marks. First line, label the triangle ABC with the given angle and sides. Step 2, write the sine rule and show substituted values. That's an M mark. Step 3, show the arcsine step, then explicitly write the supplementary angle option, or 180 minus calculated angle. That's another M. Final line, give the answers to the required accuracy, that's the A mark.
For a typical 4-mark GCSE question, you'd see M1 for setting up sin B equals B sin A divided by A, M1 for calculating an angle from that sine value, M1 for showing the supplementary angle or stating only one solution with justification, and A1 for the final labelled answer with correct degree accuracy. Write it down, don't just think it. Marks are there for method.
What if a student finds the calculator angle and doesn't think of 180 minus that? Do they lose lots of marks?
They may still get partial credit for the method, but they will lose full marks where the question expects both possibilities.
So always show the supplementary case when Sine is used in an SSA context, unless you can rule it out clearly. The quick win. 3 checks you can do in under 30 seconds when you see an SSA problem. 1. Altitude test. Compute h equals b sine a and compare to a. 2. Sine value check. Compute s equals b sine a over a. If s is greater than 1, there's no triangle. If s equals 1, a right triangle. 3. If s is between 0 and 1, compute b equals arcsine s and immediately write down both b and 180 minus b and test whether a plus each b leaves a positive third angle. That's your 30-second checklist.
Bonus micro tip. Label which answer is acute and which is obtuse on the paper. B equals 50.0 degrees, acute, or B equals 130.0 degrees, obtuse. That clarity saves marks and examiner confusion.
Worked example. Let's do an exam-style SSA problem aloud. Question. In triangle ABC, A equals 35 degrees, A equals 9 centimetres, B equals 12 centimetres. Find angle B. We'll go step by step so you can copy the layout into your answers.
So far so good. Sin b is less than 1, so there could be 2 answers.
Yes. Step 2. Principal value B1 equals arcsine of 0.7648, approximately 50.0 degrees. Step 3. Supplementary B2 equals 180 degrees minus 50.0 degrees equals 130.0 degrees. Now check each with angle A. For B1, C equals 180 minus 35 plus 50 equals 95 degrees, positive, so triangle valid. For B2, C equals 180 minus 130 plus 35 equals 15 degrees, also positive, so both triangles are valid. Write both answers, B equals 50.0 degrees or 130.0 degrees to 1 decimal place if required.
Marking note. You should have shown substitution into the sine rule, M, shown the arc-sin step, M, shown the supplementary angle or checked angle sum, M, and given the final answers correctly labelled, A. If a student only wrote 50.0 degrees but had the substitution, they'd lose 1 mark. The supplementary possibility was not addressed.
Step 4. Quick substitution check. Compute a third side to see if lengths make sense. Using c divided by sine c equals a divided by sine a, for the first triangle, c equals 95 degrees, sine 95 equals 0.9962, so c equals 0.9962 times 9 divided by 0.5736 equals 15.6 centimetres. For the second triangle, c equals 15 degrees, sine 15 equals 0.2588, so c equals 0.2588 times 9 divided by 0.5736 equals 4.1 centimetres. Both are sensible relative to b equals 12 centimetres. That substitution takes a few extra seconds and catches many errors. Don't skip the check.
I like that. A tiny calculation that proves your answers aren't nonsense.
Recap. The sine rule is straightforward, but SSA can be ambiguous. Use the altitude test, check the sine value for greater than 1, and always consider the supplementary angle. Show you're working clearly to pick up method marks. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and printable checklists at jcacademyonline.co.uk. Stay curious. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam.